A coil of wire rotates at a constant angular speed omega in a uniform magnetic field. The variation with time of the EMF in the coil is shown. The angular speed is changed to 3 omega over 4. What is the amplitude and the time period for the variation of the EMF in the coil after the change? Let's consider time period. We know that the angular speed omega is 2 pi over period, and hence period is 2 pi over omega, so time period is inversely proportional to the angular speed. And if the angular speed increases by a factor of 3 over 4, hence time period decreases by a factor of 3 over 4. And from a graph we can see that the time period is 0.8 milliseconds and decreases, so we divide by 3 over 4. It's the same as to multiply by 4 over 3. 4 over 3 is greater than 1, so 0.8 multiplied by a value which is greater than 1, definitely it's 1.1, not 0.6. What about the amplitude of the induced EMF? We know that the induced EMF is proportional to the rate of change of the magnetic flux linkage, and the rate of change is actually derivative. And we know that the magnetic flux linkage in general, it's number of coils, it's the magnetic field strength, and multiplied by the area and by cosine of the angle between vector B and vector which is normal to the plane of the coil. But when it is rotating with constant angular speed, the magnetic flux linkage becomes minus its derivative, and it becomes some amplitude value of the magnetic field strength, and multiplied by sine or cosine of omega t, and multiplied by the area of the coil, and hence the induced EMF is it's just a chain rule, so it becomes negative B0 area omega cosine of omega t, and the maximum value when it's together with minus negative 1 minus negative 1 1, so maximum value, amplitude value, is this, and it is directly proportional to the omega. So if omega increases by factor of 3 over 4, the maximum value of the induced EMF also increases by factor 3 over 4. It is 10, so it becomes 3 over 4 times 10, so it's 7.5. So D is correct, and that's all for this question.